I'm Yukiko Imada from Meteorological Research Institute, Japan Meteorological Agency. This presentation is about potential predictability of the risk of heavy rainfall in East Asia, estimated by high-resolution large ensemble simulations. So this is our motivation. Long-term predictability is higher in lower latitudes and lower in mid and high latitudes, especially for the atmospheric variables. This figure shows maps of potential predictability. I will explain the definition of potential predictability later, but here I show the target variable, heavy rainfall frequency. And in this case, we used only 10-member simulations with a 60-kilometer AGCM. As you can see, significant skew appears only in the limited areas in tropics, and almost no significant predictability in mid and high latitudes because of a small signal-to-noise ratio in higher latitudes. In addition, when we focus on regional heavy rainfall, especially in East Asia, heavy rains are often caused by mesoscale systems such as tropical cyclone and the stationary front. So the low predictability is also due to the lack of spatial resolution of the GCM. So in this study, we investigate the impact of large ensemble and high resolution on potential predictability of the risk of regional heavy rainfall in Japan and Taiwan using the large ensemble dataset, so-called D4PDF. In D4PDF, 100-member AMIP-type simulations were conducted by MRI AGCM with 60-kilometer horizontal spacing, and they were dynamically downscaled by Regional Climate Model, NHRCM, with 20-kilometer spacing from 1951 to 2017. The reason why AGCM is used is that because we know that SST has long predictable signals, so we can assume that the SST is perfectly predicted and then use AGCM to estimate the maximum of prediction skew. And the observations and reanalysis used in this study is shown here for verification. So next, I will explain the target variables and the index of predictability used in this study. The prediction target is regional heavy rainfall frequency, defined as the number of days having a precipitation of greater than 100 mm per day in each month. And as the index of potential predictability, the two indices are well known, R value and perfect model anomaly correlation coefficient. And these two indices are theoretically almost the same. So here we used the perfect model ACC, that is an anomaly correlation coefficient between randomly picked up one member and an ensemble mean of the others. And another index is actual skew, defined as an anomaly correlation coefficient between the ensemble mean of D4PDF simulations and the verification data. Here we used precipitation data downscaled from reanalysis as the verification data. So these figures show maps of potential predictability estimated by perfect model approach with high-resolution large ensemble simulations. So far, mid-latitude variability has been thought to be less predictable, but if you have a high-resolution large ensemble simulation, you can see predictable signals in some places and some seasons. And in Japan, June and July are known as a rainy season associated with the biofront, whereas August and September is known as the season when tropical cyclones are approaching. And Taiwan, it's shown here, so Taiwan has very high predictability in the east side, and it is also attacked by the typhoons. And here we examine the impact of large ensemble and high resolution on potential predictability. The left panels show the potential predictability estimated from small ensemble size and the low resolution 60 km global climate model of D4PDF. And the middle panels show the results from large ensemble but low resolution. And the right panels show the result from the large ensemble and 20 km high resolution regional climate model. So these results indicated that both large ensemble and high resolution is essential to obtain high predictability in these regions because the fine geography is important to represent the orographic precipitation. So in the next slide, I will focus on these two regions and investigate the source of the predictability. So first, we examine the dependency of potential predictability on ensemble size in these two regions and locations. The results suggested that a large ensemble size of over 50 members is necessary to detect enough potential predictability. And we also calculate the actual anomaly correlation coefficient compared with the observations. It is shown in the black lines. And we found that the actual scale exceeds the theoretical maximum of the perfect model anomaly correlation scale in Taiwan case. Such a state is called signal-to-noise paradox. One possible reason of signal-to-noise paradox is that climate models underestimate atmospheric circulation signals or overestimate noises. The signal-to-noise paradox has been observed in various scale climate prediction in mid and high latitudes. And finally, to identify the source of predictability, I calculated regression coefficient of low-level geopotential height and water vapor flux and tissue density and SST on the index of heavy rainfall frequency in each location and season. And here, the large-scale circulation fields are obtained from the global model, whereas the heavy rainfall index is calculated with the regional model. And I used 3,000 years of data from the large ensemble simulation, whereas only 30 years are available from the observation and reanalysis. So during the season of the stationary biofront in these left panels, we can see the heavy rainfall is correlated with the El Nino decaying phase and the associated Indian Ocean basin-wide warming, and also the circulation pattern, so-called PJ pattern. And in the case of the middle panel, so in this region, east side of this island, the heavy rainfall is induced by the tropical cyclone approaching. And also it is associated with the Central Pacific warming. And in the case of Taiwan, shown in the right panels, it is strongly correlated with La Nina and associated TC increase in the South China Sea. Thus, in all cases, the source of the predictability is in the tropical Pacific SST. And here the important point is that the relationship between the local heavy rainfall and the global scale SST is unclear in the observation because of the lack of samples. So the large ensemble dataset is required to obtain the significant relationship between local heavy rainfall and large-scale SSTs. So this is a summary. The long-term potential predictability of rainfall frequency lower in higher latitude due to small signal-to-noise ratio and lack of resolution to represent regional scale rainfall systems. And simulations with both high resolution and large ensemble size are necessary to overcome those shortcomings. Long-term predictable signals were found in extreme rainfall events caused by the biofront in Japan and typhoon-induced events in Taiwan that are strongly correlated with large-scale tropical Pacific SSTs. That's all. Thank you for your time.